Welcome to The Explainer. Today, we're going to put on our cloud architect hats. Our mission? To design a truly rock-solid, enterprise-grade network connection into AWS using a service called Direct Connect. This is going to be our blueprint for building a private, high-speed bridge to the cloud. So let's kick things off with a fundamental question that every single architect has to ask before they build a serious hybrid cloud. Your business is depending on AWS for its most critical applications. So can you really afford to bet the entire farm on the public internet? You know, the same internet that can get congested and unpredictable? For most businesses, the answer is a hard no.
And here's why. On one side, you've got a standard VPN running over the public internet. Just think of that as trying to drive through a major city during rush hour. It's completely unpredictable. You've got variable speeds, potential slowdowns. You just never know. But on the other side, you have AWS Direct Connect. Now, this isn't just a faster lane. This is your own private highway. You get consistent, predictable performance, dedicated bandwidth, and much lower latency. This is the whole reason Direct Connect even exists, to get rid of that uncertainty.
So, what is Direct Connect? Really? Well, the best way to picture it is as your very own private, multi-lane bridge. This bridge goes directly from your on-premises data center straight into the AWS cloud, completely bypassing all the traffic jams, all the security risks, and the general chaos of the public internet.
Now, to really get a handle on Direct Connect, you've got to look at it in three distinct layers. At the very bottom, you have the physical layer. We're talking about the actual fiber optic cable in the ground. In the middle, you've got the logical layer. This is where we use something called VLANs to basically slice that one big physical connection into separate, isolated lanes. And then right at the top, you've got the brains of the operation, the routing layer, which uses a protocol called BGP to act like an intelligent traffic cop, directing all your data exactly where it needs to go. Okay, so as the architect, your first huge decision is choosing the type of physical connection you're going to use. This is the foundation of your entire bridge to the cloud. And trust me, getting this choice right is absolutely crucial. It's going to dictate the speed, the scale, and even the cost of your whole setup.
You've basically got three main options on the table. For a massive enterprise that's pushing tons of data, a dedicated connection is definitely the way to go. This gives you your very own 10 or even 100 gigabit port directly from AWS. Now, for most mid-sized companies, a hosted connection through an AWS partner is usually the sweet spot. It offers a lot more flexibility with bandwidth. And hey, if you just want to kick the tires and run a quick proof of concept, a hosted VIF gets you a single logical lane on a shared connection, no long-term commitment needed.
All right, our physical foundation is in place. Now it's time to paint the lanes on our private highway. And in the world of Direct Connect, these dedicated lanes have a name, virtual interfaces, or VIFs for short. This is how we logically separate all our different kinds of traffic, even though it's all running over that single physical link.
The first lane you'll create, and honestly, by far the most common one, is the private VIF. This is your secure, private path from your own network directly into your virtual private clouds, your VPCs, inside of AWS. For the vast majority of hybrid cloud scenarios, this is the essential connection you'll be building first.
Next up, you can create what's called a public VIF. Think of this one as a secure private on-ramp to all the public AWS services, like S3 for storage or DynamoDB. It's perfect for things like high-speed data backups or massive analytics jobs because it lets you move huge amounts of data without it ever touching the public internet.
And finally, for those really large, complex enterprise networks, there's the transit VIF. This VIF is like the central hub of your network. It connects your on-premise world to an AWS Transit Gateway, which is this incredibly powerful cloud router. This setup is the absolute key to managing network access to hundreds or maybe even thousands of VPCs at scale in a way that's actually clean and manageable. So, just to recap, the key here is picking the right tool for the job. You've got a private VIF for your own VPCs, a public VIF when you need to get to AWS public services, and a transit VIF when you're dealing with that massive enterprise-level scale. Each one serves a very specific and important purpose in your architecture. Okay, so we've got our physical road and we've got our logical lanes painted on it. Now we need a traffic control system. This is where the Direct Connect Gateway and the Border Gateway Protocol, or BGP, come into play. You can think of them as the brains of our entire operation, directing traffic where it needs to go efficiently and reliably.
The Direct Connect Gateway, or DXGW, is your global control tower. It's a central hub that brings all your connections together. But its real superpower is that it allows a single physical connection from your data center to reach VPCs in any AWS region anywhere in the world. This is what turns Direct Connect from just a regional service into a truly global one.
And this brings us to a really critical architectural choice. It's one that separates modern, scalable cloud networks from older, clunkier designs. I mean, if your organization has hundreds of VPCs, how do you connect them all without it becoming a complete and total mess? Attaching them one by one just isn't going to cut it.
The modern answer to that problem is the transit gateway. See, the old way involved using something called a virtual private gateway, or a VPGW, but it had this huge limitation. It could only connect to a single VPC at a time. The new and highly recommended way is the transit gateway, or TGW. It acts as a regional cloud router, a central hub that connects your Direct Connect to hundreds of VPCs in this beautiful, clean hub-and-spoke model. For any serious deployment today, this is the only way to go.
Now, let's get into the brains of this whole thing, the Border Gateway Protocol, or BGP. At its core, BGP is really just a conversation between your network and AWS. Your on-premises router kicks things off by advertising the IP address ranges it owns. It's basically shouting over to AWS, "Hey, I'm over here, and I'm the destination for any and all traffic headed to these networks."
And then AWS talks back. It advertises its own routes to you. So, if you have a private VIF, AWS will announce the IP ranges of your connected VPCs. If you have a public VIF, it'll announce all of its public IP ranges. It's this dynamic, two-way conversation that allows the entire system to automatically figure out the best paths for traffic without you having to do anything manually.
All right, so a single bridge creates a single point of failure. And the final, and I would argue most critical, step in our design is building for resiliency. We have to have a high availability architecture that can handle an unexpected outage because you know it's going to happen eventually.
The official AWS best practice, the absolute gold standard for any enterprise design, is to pair your primary Direct Connect link with a backup site-to-site VPN that runs over the good old public internet. So think of it this way. Direct Connect is your multi-lane superhighway, and the VPN is your reliable emergency service road.
So here's how you actually build this automatic failover system. First, you set up both connections, the Direct Connect and the VPN, so they're both active at the same time. Then, you use a clever BGP trick called AS path prepending. This basically signals to the network that the Direct Connect path is the preferred or shorter route. The VPN path just sits there, ready and waiting, but no traffic will flow over it unless that primary path fails.
This technique is called AS path prepending, and it is just a brilliant example of how powerful BGP really is. So in BGP, every route has an AS path, which is like a list of all the networks it's passed through. By artificially adding extra fake hops to the path that's advertised over the VPN, we make it look longer to the routing logic. And routers, well, they always prefer the shortest path. It's just what they do. So they'll naturally choose Direct Connect every time. But if that link ever goes down, the shorter path vanishes, and traffic automatically fails over to the now preferred VPN path. It's seamless.
And there you have it. We've just successfully designed and built our first resilient bridge into AWS. The really important thing to take away is to understand these fundamental building blocks: a solid physical link, logical lanes using VIFs, and intelligent BGP routing for traffic control and failover. The real fun for an architect starts now. How would you combine these same principles to design an even more complex, multi-region global network? That's the next challenge.